Scientists and NASA couldn't imagine what the outcome would be when the James Webb Space Telescope was launched on the 25th of December 2021. Thousands of people explain the origin of the universe using the Big Bang. This theory came into existence through a priest named Georges Emaitre. He believed that everything we can see today, from the sun to the galaxy, began as a hot, tiny dot mixed with light and energy that later stretched and expanded to what we can see today. It was believed that the tiny dot grouped together to become an atom, then the atoms in turn grouped together to form the galaxy and stars that are visible now. The pictures of the James Webb Telescope prove that the Big Bang did not happen. How so? Let's find out. The pictures from the James Webb Space Telescope show many galaxies that are smooth, small, and old. A light was detected by the James Webb Space Telescope in one of the images, which might confirm that there's another habitable planet. The first picture captured by the JWST was released by NASA. Joe Biden named the mission A Window into the History of Our Universe. Bill Nelson, NASA's administrator, said that in time, humans will get a unique view of the cosmos differently from how it has been seen. 5 captivating images were captured by the giant telescope. As seen, stars were emitting blue-orange light. Small, smooth, and old galaxies did not show an expansion occurred, which is opposite to the Big Bang Theory. Also, according to the Big Bang Theory, there's nothing in existence before the galaxies we know today. But the discovery of old galaxies disproved that theory, showing that the Big Bang is not the absolute beginning of the universe. One of the images from the JWST revealed a galaxy named Glass Z13, which is known to be the oldest galaxy ever seen by astronomers. The JWST also captures water seen in the atmosphere of WASP 96b, a giant exoplanet that does not exist in our solar system that is about 1,150 light-years away from the Earth. WASP 96b is also called Hot Jupiter. It has a very hot temperature of over 1,000 degrees Fahrenheit. Evidence has also found that there's haze and clouds in the world's climate. For the JWST to discover molecules like carbon dioxide, water, and more on the planet that is very far away, the telescope has to point to an already known exoplanet in the Milky Way galaxy. From one of the JWST images, it discovered a lovely young star that is visible in the Carina Nebula, located 7,500 light-years away. James Webb Telescope, or JWST, is the largest optical telescope. It's more powerful than anything that has ever been sent into space. It was designed to see the entire universe. Because of its properties, it can view objects that tend to be very faint for one of the most versatile and largest telescopes, which is the Hubble Space Telescope. It was known formally as the Next Generation Space Telescope. Speed of light is one of the most prominent rules of physics that govern our universe. When talking about light, it means all the electromagnetic spectrum wavelengths that move in a staggering 300,000 kilometers per second. Light moves so fast, like a flash, that it seems to be instant in your daily life activities. However, to travel anywhere in any galaxy needs some time, despite its incredible speed. The partners in the Webb project include NASA as the lead partner, European Space Agency, or ESA, and the Canadian Space Agency, or CSA. The project has contractors in over 20 states, and about 14 countries are involved in the building of the telescope. Examples are France, Spain, Belgium, etc. It was named after a NASA administrator, James E. Webb, who prompted the Apollo program in the 1960s. The partners' objectives for building the James Webb Space Telescope are to examine how stars grow from when they begin to exist and how they fit into the planetary systems, measure the characteristics of planetary systems, both chemical and physical, to discover planets with a possible chance of life, discover the first resulting galaxies from the Big Bang, study how galaxies form and develop from the beginning to the present time. The James Webb Space Telescope operates a few points above absolute zero, which is minus 273 degrees Celsius, at a temperature of minus 266.75 degrees Celsius. It maintains this temperature by moving around the sun. It travels to its permanent home, which is Lagrange Point 2, for about 30 days. When James Webb Space Telescope gets to Lagrange Point 2, with its fully deployed equipment, the light from objects far away bounces off its hexagonal-shaped mirrors. The mirrors are covered with layers of gold, which improve the infrared vision capacity. It stays at a distance of 1.5 kilometers away from the Earth to keep and maintain its temperature around the sun. The James Webb Space Telescope is equipped with 4 major instruments. Near-infrared camera, or NIRCam, is a specially designed camera that is used to document information that aligns the 18-section mirrors of the James Webb Space Telescope together to work as one using a wavefront sensor. It's also an infrared image capture device that uses 10 mercury cadmium telluride, or HGCD-TE detector arrays. Each array has 2048 by 2048 pixels. It's an image of about 0.6 to 5 microns in wavelength, and it can capture anything close to a very bright object because it's equipped with chronographs that block lights around an object by collecting data on exoplanets close to the star. NIRCam can view 2 fields and can create imaging with both sides of the lens with accuracy finer than human hair, about 93 nanometers. This enables it to observe magnitude plus 29 fade objects with an exposure of 10,000 seconds. Near-infrared spectrograph, or NIRSpec, is capable of measuring 100 objects with near-infrared spectrum simultaneously. Examples of objects like that are galaxies or stars that have either low, medium, or high spectral resolutions. It's also used for individual source spectroscopy of high contrast with appropriate aperture and slit set. It can observe over 3 Arcmin by 3 Arcmin field of view. Mid-infrared instrument, or MIRI, is both camera and spectrograph that see longer wavelengths of light than the other instruments on JWST. It's designed to see mid to long infrared radiation, like NIRCam, and it's also equipped with chronographs, which block lights around an object, so it's also used to observe exoplanets. The spectrograph view is small, while the imager view is wide. Fine guidance sensors, near-infrared imager, and satellite spectrograph, FGS/NIRISS. FGS's main purpose is to help the telescope stay pointed to anything that is directed to view and make the aiming accurate. NIRISS's main purposes are aperture masking interferometry, near-infrared imaging, wide-field slitless spectroscopy, and single-object slitless spectroscopy. The 2 instruments are physically combined but functionally separate. Celestial objects are detected from the ray of light they emit. Objects that are hotter emit radiation with shorter wavelengths, like ultraviolet light. Objects that are cooler emit infrared light that cannot be seen by the human eye. Abel Mendez, director of the Planetary Habitability Laboratory at the University of Puerto Rico and the Archaeobos, said, "I'm amazed by the resolution and sensitivity of JWST. This is a game changer for understanding and discovering new astronomical phenomena." Among many of his expressions regarding the JWST, Ilya Mendel, a professor of theoretical physics at the Monash University, stated, "There's much more to come, and I'm looking forward with great excitement to seeing the capabilities of the James Webb Space Telescope trained on other astrophysical puzzles, including cosmic transients such as the mergers of 2 neutron stars, which may be responsible for the production of much of the gold in the universe." Dr. Catherine Gracia is an ARC-DECRA Fellow and an Astro 3D Fellow at the Australian National University. She said, "The James Webb Space Telescope matters to me because with the first light of JWST, we will have an unparalleled opportunity to view the birth of stars within the hearts of the densest, dust-enshrouded cores of molecular clouds. The technological advancements of JWST will build a revolutionary dataset to the astronomical community, spur major scientific advances, and build on recent legacy programs of the Hubble Space Telescope that revolutionized our knowledge of the cosmos. The James Webb Space Telescope is a big deal to researchers. It will be of help in many ways. It will enable researchers and scientists to learn the depth of the history and makeup of our solar system. It will also help in finding out if other planets could support life." If you like this video, please subscribe to our channel to be notified when we upload more content like this. Also, don't forget to click that like button and leave a comment below. Thanks.